So our next speaker for the day is Karan, who will be speaking on DevOps practices at GitHub. Karan leads the international developer relations for GitHub. He is on a mission to help every developer be a part of the open source ecosystem and grow their software development skills through the power of GitHub. He runs programs to support developers' learning journey and helps open source projects grow, and the engineers to better the use of GitHub in their development workflows. Please welcome Karan to the stage.
Great. All looks good. Can we bring the presenter over here, please? I mean, the slides. I'm the presenter. OK, great. So if you can't hear me at any point, please let me know. I'm in staging environment. You people are in production. OK? These speakers are literally different. So everyone's been talking, all the speakers have been talking about how the clicky thing doesn't work. I'm smart enough. I bought my own one. OK, great. So a little bit quick thing about me. I am not Tony Stark. I am Karan, and I lead international DevRel at GitHub. So working a lot with developers, communities, and I'm very, very passionate about cloud, DevOps, open source. And when I'm not working or doing any of these things, you can find me read a lot of books, and then also do some acting, anchoring, and then interested in filmmaking in other states. So a little bit about that. OK, so I'm going to keep this behind. I'm used to that. All right, so DevOps practices at GitHub. OK, so in case you're wondering why is this here at RUBYCONF and things like that. So let me tell you that GitHub, of course, largely is built on Rails. So the monolith itself is a Rails app with a ton of other microservices and everything else. So I just want to share very, very few quick, or rather exactly 3 things. Okay, one is some of our practices when it comes to the code aspects of our code base, and anything that you speak about DevOps these days is not complete with CI/CD. A little bit about that, and also a few things around developer productivity itself. Okay, so but before that, you might be wondering, like, how the hell do you measure all of these things? There are a lot of other, industry standards and things like that. And, the key metrics that we ourselves use, of course, is the same as the DORA metrics, which is essentially around the deploy frequency, how frequently is the team deploying, and then, the lead time for changes, how long does it take for the code to, run in production, and then time to restore the surface. Say in case there is an incident that happens, how long does it take to get up and running, and then also the change fail rate, right? So how much percentage of changes, to production result in a degraded service? Okay, so those are the things that we measure. I'm not going to be diving more deeper into this one. But let's go on to the first part, the code part itself, all right? So one of the things that many people ask me is like, how does GitHub manage the Git branching strategies and things like that? Everyone is always curious to know about that. And let me tell you one thing. We don't use long-lived feature branches at all. Okay, this comes as a surprise to many people. Are like, oh my God, how do you even develop? There are a lot of advantages to not using all of these long-lived feature branches. Is because one, as you can guess, no merge conflicts, because people might be working on the same branch in multiple times, etc. And also most of the times when we are working at GitHub, the smaller changes in a pull request are more easier to review than all of the big feature branches with multiple codes and things like that. And also, since the smaller, the modular the code is, and when you deploy it into production, something goes wrong, it's easier to roll back, right? But one of the other things, and I'm going to come a little bit around the branching strategy a little bit later. The other thing that I want to mention about is you might see GitHub release a lot of features, a lot of new things, etc. So how do we manage some of those things? Okay. We use something called as feature flags. Okay, I'm not sure if many of you are familiar, or if you use, in a continuous, deployment or continuous delivery environment. But there are a lot of gems as well that help you with this in the Ruby world. But we have our own, feature flag gem. So essentially, what this helps us is really to kind of roll out new features without risking production breaking down. Okay, so what it really helps us is that when we're kind of working on a new feature, we put it behind a feature flag so that once we deploy that particular code, we are able to kind of turn that on easily, either for everyone, individual actors, or a certain percentage of actors and things like that. And this is also very helpful for us when it comes to testing all of these features, okay? Because we can kind of go ahead and test all of these features within our CI pipeline. So in fact, within our CI build, we have like 2 builds that happen for every time there is a build that goes on. One is with all features that are enabled, and one with none of the features enabled. It gives us a better code coverage. And also, we can kind of enable or disable features for certain tests, when you're running a certain test suite and things like that. And also the other aspect is that we can also test features in the production environment by kind of really passing query strings and requests and things like that. Okay, so that's one thing. And also we have multiple shipping strategies. Remember I told you the first thing was it really helps us ship features much more easier and faster. So we have multiple strategies of how we really ship features, whatever it is that comes new. The first thing being, individual actors. We can actually turn the feature flag on and off initially for the specific team members, or if there is a customer who is, kind of figuring out a problem, turn it on and then kind of try to fix it. The other thing is when we're kind of working on bigger features, right, we do something called as a staff ship. So what the staff ship does is it enables the features for all of GitHub employees so that we can get, like an alpha, so that we can get some more feedback from everyone at GitHub to kind of test it out. And once that's done, depending on whether it's a feature for open source maintainers or for a certain audience, we then kind of start rolling it out to some of those early access maintainers. This is essentially the beta phase where we're able to change that feature flag and roll it out to some of the other beta group users as well. Certain kinds of users or customers and things like that. And then once this is done, when we actually start rolling it out, we usually what we do is we roll it out to a certain percentage of actors sometimes. So we can actually define that, okay, I want 10% or 20% of the actors for this feature flag to be enabled. So once someone is like enabled and flagged in, they're able to have it always ready. A little bit different variation to this is we also do dark shipping, and dark shipping is essentially where it's not a percentage of actors, but a percentage of calls. Calls to an API, calls to a request, calls to a specific module or whatever it is. So one time it might be enabled for a certain actor, the other time it might not be enabled. And this, of course, like how you can imagine, it's not for user-facing or public-facing parts, but it's largely probably something behind the scenes, say performance optimization or different queries and things like that. All right, so quite some stuff that we do there when it comes to shipping stuff itself. So that was, a little bit insight into the code part. Now comes, some of the things. The second thing that I want to talk about, which is a little bit around the CI/CD part, and I think this is, my favorite, my interesting part as well. So I want to talk about one challenge rather that we kind of overcame, which might be helpful as a takeaway. So before this challenge came in and before we kind of tackled it, this was what our CI really, used to look like. So for a CI suite to complete, before merging any changes, it used to take like 45 minutes. And again, and after merging the branch as well, after deployment, that used to take again 45 minutes for the CI suite to run. So overall, it used to take almost like 2 hours, right, from checking in the code to kind of going live on GitHub. That was quite a lot of time. And right now, our CI almost is 3x faster. Takes 15 minutes, okay? And you might not get the context of how fast this is, but I'm going to come to that in the third story when I talk about the Ruby monolith itself of GitHub. So what really happened over here? How are we able to make this faster? For this, I want to give a little bit, background around there is the GitHub Ruby monolith. So there is almost around 7,000 test suites, around 5,000 test files, and there's almost 25 CI jobs that run on every commit, okay? And and also, among these 25 CI jobs, 15 of them must complete before, or not complete, but must pass before, you kind of really actually consider merging these changes, okay? The rest are, kind of optional. It can complete or not, etc. But 15 of them really have to complete, okay? So I told you I'll give you a little bit background about GitHub Enterprise Server. So, like how I mentioned, the GitHub.com is a monolith. So GitHub Enterprise Server is, an offering for enterprises that is kind of on-premise as well, and it comes from the same GitHub.com monolith itself, okay? And what GitHub Enterprise Server, before this was doing is it had 2 long-running test suites that itself was taking 45 minutes, each time to run. And then what we realized was that, hey, wait, why should we wait for this GitHub Enterprise Server test suite to complete for a GitHub.com deployment? Okay, so there had to be a balance between the, what you're kind of wanting the velocity for a GitHub.com deployment versus, having something both which is reliable and also accountable for the GitHub, Enterprise Server. So it had to be a balance because it all comes out from the same monolith. So that's when, the teams internally created the Deferred compliance tool. Okay, I really love this. I think it's really beautiful. Wherein we kind of try to balance both of these things together. So how that's done? Let me show you that with this specific graph. Okay, so for example, when a developer creates a PR to merge a change, not or whatever that is. Sorry for the typo. So the required CI jobs, like how I said, are supposed to succeed. And the long-running, non-required CI jobs kind of keep continuing. Okay, so as soon as this required CI jobs all succeed, the pull request can be merged and deployed. And if the long-running CI jobs succeed, then well and good, you are in the happy scenario, happy path. But if it doesn't succeed, what the tool does is it also integrates with our CI workflow for this to happen, and it creates a GitHub issue. All right, and what the GitHub issue does is it says that, hey, the long-running CI job kind of really failed on this particular PR that you created. It tags the code owner, the PR author, and everyone. And a timer is started for 72 hours. Okay, it's customizable, but we've kind of figured out that the 72 hours is a good way because if someone does, a commit in San Francisco on a Friday afternoon, it doesn't kind of make things, hurried for a developer in Sydney, say, working on it on a Monday morning or something like that, right? So, so then when the developer comes and then kind of fixes the broken test, does a revert of the PR or does a push, etc., and then the long-running CI jobs succeed, then well and good, the issue is closed. But again, if there is no update on it for the next 72 hours, then a trigger gets raised, and then there's an escalation that happens, and all deployments get blocked. Okay, so you see here what really happened is that, one, we made our CI faster. Second, there is accountability that the CI jobs run. And third, the velocity for deployments for GitHub.com itself doesn't get affected. Okay, so that was one thing. So this is something around the CI part, right? Talking a little bit about the deployments aspect itself. I told you first of all, that we don't really use long-lived feature branches, and also a little bit of our deployment mechanism is also very different. So what we do is we use the branch deploy model. Okay, I'm not sure if many of you might have heard about it, but what we do is we deploy the branches first before merging them into main. So that way, the main branch is always stable, and then if something goes wrong with the deployed branch, you can always redeploy the main branch to kind of roll back rather than diff out your PR, diff out your whatever was the change that was introduced and things like that. All right. So how this used to happen is that we have an internal Slack channel called .com ops, where essentially developers go and then run a chat ops command to go ahead and then deploy a certain PR, and then because we use that branch deploy model, each PR is on a different branch, and then you can kind of really combine all of the branches together, be in a queue, and then deploy, etc. So it used to look something like this, where a developer goes and then does a dot deploy a certain branch to canary, etc., and then all works well. But the challenge, with this approach was that as and when teams are growing and the number of developers who are actually going and then deploying continuously increases, this channel, broke all hell, all right? Because it was just having so many deployment messages and everything else, and it became very difficult for people to catch up with. So that's when we decided to go ahead and then use a state machine model to really think about how we go ahead with deployment itself. So what that state machine model looked like was something like this. So there was a pointer that we kind of maintain in the data model to look at what are the different states and progressing through the states. So we do a first of deploy to 2% canary, and then kind of progress to 20% canary, and then kind of deploy that branch to production. And then once the production deploy succeeds, we do a go ahead and ready to merge. And then there are automated timers between each state, so that will give developers enough time to test their change, and it kind of, if something goes wrong, they can quickly block the progression, roll back, or even lock the whole deployments itself. Okay, so and there was again like a data model. So and to kind of really manage this more easier, we built a first-party UI component to manage all of these things. And this is something what it looks like, where you can see there are multiple users who can go ahead and queue up branches for deployment. And the stages which I mentioned, you can see on the right, where there's deploy to canary, a timer gate of 5 minutes, and then 20% canary, and then deploy to production and things like that, right? So what this meant was, along with this, there was one other first-party UI component page that we had that showed what was happening with each specific pipeline deploy as well, which looks something like this, where a developer can really go and then look at okay, what's the deployment to canary, look at the logs, and then there's a timer gate that runs, and see how that goes on. And there are again other things that are there of locking a deploy and all of those things that's there. So in a nutshell, the way that it really works for us at GitHub to kind of go deploy is we still go back to the same .com ops channel, but we kind of use this pipelines to go ahead and deploy it, so that a developer really has to go and then say that, okay, I deploy this specific branch, and then come back and then look at the pipeline in the UI component and kind of get going. So it makes things very faster, and then we kind of try to bring together a lot of other branches and then group them and then deploy them, so that it's much more faster. Okay. So that's about a little bit about the CI/CD part of how we go about it. The developer productivity, again, is a very interesting thing for me. Okay, so I'm not sure. I find it funny that I'm using someone else's laptop here to present, but that's exactly what we do for GitHub.com, development as well, because GitHub is being built using GitHub Codespaces. Okay, so in case you aren't aware, what is Codespaces? It's a remote cloud development environment, by GitHub, wherein you can really start a cloud VM and then configure it however you want, and then go ahead with your development, deployment, and everything else. Okay, and So the challenge, what happened is that initially, while we were kind of really looking at the productivity, so GitHub, okay, I'm going back and forth, but because it's a very interesting story, is that when GitHub had its first commit, right, almost I think more than 14 or 15 years ago, Rails was just a couple of years old. And then what happened was we kind of went ahead and then looked at all of the commits, more than 1 million commits on the GitHub monolith, and then we saw that most of the commits are from developers who are building and testing on Mac OS itself. Okay, and it's a huge code base, which is almost around, I think, 13 GB or 15 GB or something like that on disk itself, the entire monolith. And what this used to create was, this was the general way how developers were really doing it. Do a git clone of github.com/github/github. That's the monolith. Don't try accessing. You won't be able to access. And then you do a CD, and then we have we have this, pattern called as scripts to rule them all. It's open source. You can go GitHub/scripts to rule them all. Basically, a pattern which says that, okay, script/bootstrap, in any project really does all of the bootstrapping, installing the dependencies and everything else, and then, script/setup does everything else that's required after bootstrapping, like, running migrations or whatever else is required, and script/server brings up, the server. So every developer, had to do something like this. But again, like how I mentioned, the challenge was that, okay, if you're wondering what the nuke from orbit is, the challenge was that, like how I mentioned, 13 GB on disk, and the cloning itself used to take 20 minutes. The first time when I started doing this, I was like, go grab a cup of coffee. Still happening, and entire thing used to take almost like half a day. All right, and the reason is this was an infamous command line argument that was given, says nuke from orbit, because if a dependency goes wrong, you just want to clean the slate, right? So it's like almost like script/setup nuke from orbit, script/bootstrap nuke from orbit or something like that. So to kind of wipe the slate clean. So it was really a challenge. It was like almost like a half day's effort just to do a clone, bootstrap, setup, and then start development itself. 13 GB, on disk, and 20 minutes for just cloning it, onto the Mac. So that was when, we thought, okay, we need to kind of really address this thing. And that's when we said, well, like, why not use a remote development environment, which is, like now, Codespaces. So what really happens with, Codespaces in the backend, or, oh yeah, this is a very important number. It takes 45 minutes just for the bootstrap process to complete. Okay, so 20 minutes for cloning, 45 minutes plus for just bootstrapping itself, and then again for the setup and server and all, it takes a much longer time. So what happens with the code space behind the scene is that when someone goes and creates a code space, not just like at GitHub, but even publicly, is that a dedicated and private VM gets created. And then, the GitHub repo, wherever the code space was started, gets cloned. And then, the GitHub repo within the VM. And then that gets attached to a container, which the user can access. So the container will have VS Code as well, which you can use it either in the web or, you can connect your instance and things like that. Okay. So what we did was, again, we wanted to speed up this time, for developers to quickly go up and running. So what we did was this part, essentially around cloning. All right, I don't know why it went off over there, but essentially around cloning, right? A simple thing. We were doing a full clone, but said, hey, let's do a shallow clone instead of a deep clone, like a depth of 1. So what this really helped was bring down that 20 minutes or so of cloning time with a shallow clone into something which is much, much more lesser and then faster. Okay, and then thinking about, that was the clone challenge. If you see in the scripts tutorial and all, the first thing was clone, and the second thing was bootstrapping. Okay, now anyone, if you're thinking about, like, hey, where the hell does, containers come into play? And that's exactly what Codespaces also helps us with in the containers, because developers don't have to go and then kind of create all of that bootstrapping and everything else from the first. What we did was we used GitHub Actions itself to run a nightly to kind of build and push a Docker image with all of the dependencies that was there. Okay, so the cloning part was taken care of, and then after that, the dependencies, the bootstrap part also was taken care of. So what this led to was, from 45 minutes for a developer, it came down to 5 minutes. I have literally, when I did use this for the first time, I was like, oh, thank God, 5 minutes kind of a thing versus waiting for such a long time. But, if any of you have known GitHub, we are very ambitious, very, very ambitious when it comes to things. And then, many of the teams were like, let's break it down to 10 seconds, like 10 seconds. You just start it, and then the entire GitHub monolith should be ready to up and running and getting things done. How many of you think we did it? Oh, wow. I really love that. There's just 2-3 people. Others are like, nah, ye fekta hai, ye kitna fekta hai, Well, there was one challenge, of course, which happened over here, is that there was the cloning part that happened, and then there was also the bootstrapping part which happened, right? But what it meant was, going back over here, is that this entire thing had to happen again to create a private VM, to create a container, to clone, and everything else. All right? And that's where we brought about something called as pre-builds, which are basically pools of code spaces, which are fully cloned, bootstrapped, and a container which is ready to get up and running, so that it's very, very easier for a developer to just say, create a code space and have the github.com, monolith up and running. And in fact, this worked out so very well for us that pre-builds, later we decided to launch it as, part of Codespaces as well, so that people can, use the same feature that we built actually for ourselves to make things faster. And you know what? For all of you who didn't raise the hands, we did it. 10 seconds, we did it. And trust me, this is still the case. This is still the case, okay, that in 10 seconds, you can get the entire 13 GB of github.com monolith ready, bootstrapped, up and running, simple PR, entire feature from a branch, from main, whatever it is. And in fact, many developers, we have a separate kind of a staging environment. They stopped using that. They say, Codespace pe chal raha hai na? That was how it was. Okay? And the best part here is, which I kind of conveniently skipped, is that as and when more features are growing, all right, you can just quickly change the capacity of the code space, saying that, okay, I don't need the 16 GB memory anymore. I can, just increase 64 GB, and then, things are up and running and good to go. So it shows my time's up, but thankfully, I am done. Okay. So 3 things: code, CI/CD, developer productivity. Thank you, everyone. And the only reason why I've included that photo is before all of this time in the conference, I've seen people looking at me. I know I've changed, but that's me, what you would see in photos. Okay? So thank you, everyone. And I don't know if we have any time for questions for a minute or two, maybe.